So I'm going to take a look at problem 5-14 right now. Uh, so some similarities, there's some things in common from the previous problem 513. Um, One of them is we have a uniform distribution. And what our expectation here is that we'll have this force times the distance from here to here will give us a this distributed force in newtons per meter um, times the distance from here to here, and we multiply that, and then we'll come up with the total force. And then what we recognize is it's going to be halfway between here and here. Okay. And so what we need to do here is come up with a reaction. So this is just a roller support essentially. So it doesn't resist any motion back and forth this direction, just vertically. Okay. Now, so we're going to have a reaction here, only in the y direction. And then over here, we have a pin support. So this one will not resist rotation, but it resists translation in the x and the y direction. Okay. So this one here, we'd have two reactions. So like the previous problem, what we're going to do is we're going to have three reactions to solve for. Okay. So we're going to look for AY, BX, and BY. Okay. And so I start off with a free body diagram. And as part of that, I write down the distances, 4 meters, 3 meters to here. This is my AY, my BY, and BX like I talked about before. Now we needed to find the length of this beam. Okay. Well, one of the things you'll recognize is this side over here is 4. This is 3. Then, of course, for a right triangle, this side has to be 5. Okay, and it's easy to figure that out. You just do 3 squared plus 4 squared gives you the 5 meters. So now the length of this is 5. So what we're going to have is to come up with this. Oh, see, this should be 5. Cross this out. This is 5 meters, and this is 800 newtons. So this gives you the actual force. So this is a mistake here, but the calculation is correct. It's 5. This should be a 5 here. Okay, so make that change. So 800 times 5 gives us the 4,000. Okay, and where does it actually act in this place? Well, it's going to be, this is 5, so it's going to be 2.5 meters from there, from this point. Okay, all right. So we can continue on with this, and we have our governing equations, right? The usual. Moment about any point is equal to 0. Summation of the forces in the x direction equal to 0. Summation of the forces in the y direction equal to 0. Okay. So we're starting off with 3 unknowns. First thing we'll do is, for this problem, we'll do moment about b. Okay. So then with that, if we do moment about b, we're going to have something here that contributes to our moment, the force here, and then something here. Well, the first part is what you recognize is that this is, we know the distance from here to here, and this force is acting at a 90-degree angle with this, so it's perpendicular. So what we can do very simply is just multiply 2.5 times the force. So it's going to be the 2.5 times 4,000 gives us the magnitude for this part. And, this is going to be 10. And then AY is this force. And if you draw this line of action straight down, straight down, straight down, and you drew a line straight out, what you recognize is this meets at 3 meters. So meets it at a 90-degree angle, 3 meters from this point. So it's just going to be AY times the distance from here to here, which is 3 meters. So you can go and solve for that very easily, and that comes out to be 3.33 kNewtons. Okay. The next thing we'll do is we're going to do the summation of the forces at x. Okay. Now, if you look at it, you see this doesn't contribute anything. This reaction doesn't contribute anything in the x direction. It only contributes in the y direction. So you don't have to have that as part of your. It will not show up in the x equation, summation of the forces in the x direction. But there is a component here. Now it's going to be the 4,000 times 3 over 5, following the law of similar triangles. So this 4,000, which is just right here, 4,000 newtons times 3 over 5 gives you the x component. And you'll notice that that's negative because it's in the negative x direction. Okay, so it's this part right here. If you were to draw it out in its x component, x and y components. Okay, so we just solve for that, and then we get 2.40 k-newtons. Okay. And the last part here, we're just going to do the summation of the forces in the y direction and set it equal to 0. We could have done the moment about another point if we wanted to, but this works out well also. Okay, so here is the force in the y direction. Here's my AY component, okay, which is going up. Here is my y component of that force, the distributed force acting at that center point of that bar, and it's going down. And then by, and by is going up. In this case, at least in my free body diagram, I had it going up. So just taking a quick look back at the free body diagram, by is going up, ay is going up, and then my y component of my force is going down, of this force, due to the distributed, the centroid or the center point of that force. Okay, so this is positive, positive, and then negative. So in this problem, you solve for by. So here's my components. The only unknown is by. Solve for that. Comes up to be 133 newtons. It's negative. So because I had it defined as by is going up, the negative sign just means that really the reaction is going down. Okay, so meaning that it's trying to stop the end of the bar from lifting up, essentially. It's pulling a force down. Okay, so the bar is trying to lift up at point B, and this force is pulling down to keep it in place. Or the reaction's pulling down to keep it in place.